All right, believe it or not, I've already done this once, and we're going to try to do this again. Because this is how this WebEx works. It doesn't always work for you. It doesn't always work for me. So we're going to try 6.2 again. I know you didn't see the first one. Now we're going to do it again. All right. Remember the rules of factoring. I said you start out in 6.1. We talked about this. First, you look for the GCF, greatest common factor. What can I take out? And then you look at how many pieces. And remember, in 6.1, we had 4, which we learned that we had to group in order to factor. Now, if there's 3, it's just plain old factoring, okay? But you have to decide if it's the easy kind or the hard kind. So let me put something up here, and let's talk about it. A squared plus 9a plus 20. We have to figure out how we can put it into a multiplication problem. Well, as long as whatever's in front of the letter that's squared is 1, it's the easy kind, okay? Because how can we get a squared? We can get it by multiplying a times a. When we multiply a times a, you'll get a squared. Now, the second part of the parentheses comes from the last number. 20 is either 1 times 20, 2 times 10, or 4 times 5. We don't know which one, but what tells us which one is this. Which ones add up to 9? 4 and 5 add up to 9. Now let's look what we get. When you multiply the outside, you get a 4a. When you multiply the inside, you get a 5a. We need to add that to add up to 9a. We need it to add up to a positive 9a. So they would both have to be positive. All right, let's look at another one. What if I had x squared minus 7x plus 10? Okay, nothing we can take out. How many pieces? 3. Easy kind, because the 1 is in front of the x squared. So I know I get x and x. Now, I'm looking at 10. 1 times 10 or 2 times 5. Which one do I use? Well, which one adds up to 7? 2 and 5. Now look what we get. On the outside, we get a 5x. On the inside, we get a 2x. That adds up to 7x, but we need it to add up to a negative 7x. So they both have to be negative. All right, let's try some more. The more you see these, the more they'll make sense. Okay? What if I had y squared minus 2y minus 35? Okay? We know in order to get the y squared, this is the easy kind. There's nothing we can take out. 3 pieces, easy kind. It's y and y. Now look at 35. 1 and 35 or 5 and 7. Which set subtracts to give you 2? Well, that would be 5 and 7. On the outside, we get a 7y. On the inside, we get a 5y. If you subtract, that gives me 2y. But I need a negative 2y. So I need to keep the sign of the larger when I subtract. So 5 gets a positive, 7 gets a negative. All right, what if I had x squared plus 3x minus 5? That's a minus. Okay, nothing you can take out. Easy kind, x and x. Now look at 5. That's just 1 times 5. Does 1 times 5 subtract to give you 3? No, it doesn't. So my answer is not factorable, and that could happen. Okay? All right, let me show you what else could happen. We could have something that looks like this. P squared plus 6AP minus 16A squared. Well, there's nothing I can take out. And to get P squared, I know I have to have a P and P. Now, looking at the the last thing, we're going to look at the number, but it has an A squared with it. So can you see that we would need an A and an A? Now we just have to deal with the numbers. 16 is 1 times 16, 2 times 8, or 4 times 4. Which set subtracts to give you 6? 8 and 2. Now what happens when you multiply P times 8A? You get 8AP. What happens when you multiply 2A times P? You get 2AP. And they need to subtract to give you 6AP, and the 6 has to be positive, so that means 8's positive and 2's negative. So 8's positive, 2's negative. And you're done. So just because they add a letter at the end, you just add the letter at the end and you're good. All right, what happens if I have this? 16y cubed minus 32y squared minus 48y. 3 pieces. What's the first rule of factoring? What can I take out? Look at 16, 32, and 48. You actually can take a 16. You can divide by 16 each piece. And do they all 3 have y's? Yes, they do. You divide out the smallest exponent, which is just 1. So I can take a 16 and a y out, which leaves me with y squared, because 16 to be gone. You have 3 y's minus 1 y gives you 2 y's. 32 divided by 16 is 2, and y squared divided by y leaves you 1 y, minus 48 divided by 16 is 3, and the y's are gone. Now let's see if we can take what's inside here and go farther. I would need a y and a y. 3 is 1 times 3. Does a 1 and a 3 subtract to give you 2? Sure does. Now, on the outside, I get 3y. On the inside, I get 1y. Subtract, I get 2y, but I need the 2 to be negative. So it would have to be negative 3 and positive 1. So there's your answer. You don't get to forget the 16y. It's got to be there. It's 16y times y plus 1 times y minus 3. Still all a multiplication problem now. Okay? Now, what if this is what I got? 3x squared plus 7x plus 2. Now, okay, number 1, is there anything I can take out? No. Number 2, there's 3 pieces when I ask how many. Is it easy or is it hard? Well, this time it's hard because there's a number in front. This is how we do it. Whenever there's a number in front, you can't just put parentheses. You can't just put parentheses and go x and x. You can't do that, okay? So what you do is you take and you multiply the first number and the last number, which gives you 6. That's your magic number. Think of the multiples of this number, 6 and 1 or 3 and 2. Which ones add up to 7? This. So we're going to rewrite the problem. We bring down the first, we bring down the last. We rewrite the middle using the 6 and 1 to get 7x. So we need a 6x plus a 1x. Is 6x plus 1x still 7x? Yes, it is. But we've expanded it now to 1, 2, 3, 4 pieces. So what do you do when there's 4 pieces? You group. Got a plus in the middle so I can group like normal. And then we go through what we did last time. What can I take out of 3x and 6x? I can take out a 3. And what am I left with? X plus 2. Plus, what can I take out of x squared or x and 2? Remember, if you couldn't take anything out, what is it that you put out on the outside? A 1. You still have to take something out, so you make it a 1. 1x is the same as x, so it's really x plus 2. Now, what do they have in common? What can I take out of each of these? An x plus 2. And what is left? Oh, I needed to take an x out of here. So because that gives us x plus 2, sorry. What's left? 3x of 1. Back up here, look again at what I just did. These both, I could take a 3 out, and this was an x squared, and this was a regular x, so we needed to take at least one x out. So I took one x out, so you left a 3x plus 1. All right, let's look at another one. All right, what if I had 6m squared plus 7mn minus 5n squared? Again, greatest common factor, there's nothing we can take out. It is 3 pieces, but it's a hard kind. So we have to take and multiply these two numbers, 6 and 5. Regardless of their sign, doesn't matter, 6 times 5. What is 6 times 5? 30. 30 can be 3 times 1, it can be 15 times 2, it could be 10 times 3, or if it could be 6 times 5. Which ones subtract to give you 7? 10 and 3. So we keep the first, we keep the last, and we rewrite 7mn as 10 minus 3. 10mn minus 3mn. Does that give me a positive 7? Yes, it does. Now I have 4 pieces. So what do I do with 4 pieces? I group, but I got a negative there. So remember to group it this way, and it'll help remind you to take it out negative. All right, what can I take out of 6 and 10? I can take out a 2. Do they both have an m? Yes, they do, and the smallest exponent is just the 1m. So I can take out a 2 and an m. What am I left with? 3m plus 5. All right? Now, whatever I take out of here, I'm taking it out negative. Between 3 and 5, nothing. M, no. But do they each have at least one n? Yes, they do. So I can divide out a negative n. All right? Now, negative and negative makes a positive. The n's go away, so I'm left with 3m. Negative and a negative makes a positive. I'm left with 5n. Oops, I forgot the n here. Now, it's still an addition or subtraction problem, but now what do they have in common? They each have a 3m plus 5n, and what's left when I divide out that 3m plus 5n? We are left with 2m minus n, and there's your answer. All right, let's do another one. Let's do another one. The more you see the pattern. All right, what if I had 12x squared minus 5x minus 2? Is there anything we can take out? No. For the easy kind, no, because we have a 12 in the front, so we have to multiply. 12 times 2 is 24. 24 can be 24 and 1, 12 and 2, 8 and 3, 6 and 4. Which ones subtract to give you 5? 8 and 3. So we're going to rewrite that middle number using 8 and 3. We don't change this one or this one. Now, to get a negative 5, it would need to be negative 8x and positive 3x, using the 8 and 3 to get a negative 5. All right, now we have 4 pieces, so we group. And this time it's the pluses in the middle, so it makes it easy. Okay. All right, what can we take out of 12 and 8? Take out a 4, and then they each have an x, and the lowest exponent is a 1. So I can take a 4x out of both. 12 divided by 4 is 3, and x squared minus 1x is x. Minus 8 divided by 4 is 2, and x is gone. Plus, what can I take out of 3x minus 2? Nothing. So what is it you take out? A 1. You just write the 1. Now, what do they have in common? They both have a 3x minus 2. So when I divide out that 3x minus 2, what am I left with? 4x plus 1. And now it's factored. Okay? Starting to see the pattern there? All right, one more, and I'm going to try to trick you because I'm going to give you something that we have more steps to. It's still nothing that you don't know, but we have more steps. Because what is the first rule of factoring? What can I take out? This has something that we have to take out. 16, 24, and 16, we can at least divide out an 8, and they each have y's, and the smallest exponent is a 1. We can take an 8y out. We're left with 2y squared plus 3y minus 2. 16 divided by 8 is 2. Y cubed divided by y is y squared. 24 divided by 8 is 3. Y squared divided by y is y. And 16 divided by 8, or negative 16 divided by 8 is negative 2, and the y's are gone. Now we have 3 pieces, but we do have something in front of the y, so we have to multiply. What's 2 times 2? 4. That's the magic number. 4 and 1 are 2 and 2. Which one subtracts to give us 3? 4 and 1. Now we're just going to bring this 8y down to the very end, okay? Don't forget, that's on the outside, so it has to be on the outside. But let's deal with this. All right, we're going to rewrite 2y squared and negative 2, and we're going to take and make 3y out of 4 and 1. So it would have to be plus 4y minus 1y. That would give us a positive 3. All right, now we have 4 pieces, so we have to group, and this time we have that negative, so group the negative inside to remind us. What can you take out of these? Well, they each have a 2, and they have at least one y. So I'm going to take a 2y out. I'm left with y plus 2. Now, is there anything I can take out of a y and a 2? No, but when there's nothing you can take out, it's a 1. And what kind of 1 does it have to be? A negative 1. So if I divide this by negative 1 and that by negative 1, I get y plus 2. Now, what do they have in common? We can take out a y plus 2. And what are they left with? 2y minus 1. And there is your answer. So you had one more step. It was taking out the greatest common factor, and you just put it on the outside at the end. All right, that's 6.2, and there's a lot of practice in there because you just have to keep doing it to get practice, because this is a little bit of a reasoning type thing. All right, you've practiced 6.2, and let me know if I can help you with anything. All right, bye.